firefighting experts.
It was the combination of the impact load doing great damage to the building, followed by the fire, that caused collapse.
Well, where did he get that? That's Gene Corley with the American Society of Civil... Oh, he got it from the guy on the street program. Well, fortunately, we have very different and identifiable characteristics with these forces that destroy buildings. Like, for instance, fire destroys buildings quite differently, the features from a controlled demolition. Explosions have a whole different set of features. And earthquakes cause buildings to topple very differently as well, in a natural type collapse. So let's look at fires for just a moment. Fires, by their nature, are organic. They work themselves through a building every 20 minutes or so, burning out one area and going on looking for fresh new fuel sources. So when a building does collapse due to fire, it's a large, gradual deformation, and it falls over. It follows the path of least resistance, not straight down through the structure. And never in history do we have an example of a steel frame high-rise that's collapsed. But say in a wood building, it'll be an asymmetrical collapse. So keep this in mind. And we'll talk about what fires are expected to do in steel frame buildings in a moment. But these buildings fell over by natural forces, earthquakes. They fall over. Their structural skeleton is not dismembered. You see what was a building at the bottom of the pile, mangled certainly. The concrete is not pulverized to powder. So keep this in mind. Explosions are quite different. They have thick, billowing, enormous clouds of pulverized concrete. And from the expansion of gases, it's like a pyroclastic-like flow, cauliflower formation like you see in volcanoes. That's where the term pyroclastic comes from. And we have witnesses that hear sounds of explosions and they see flashes of light. So keep this in mind. Now let's take a look at controlled demolitions. Fortunately, we have hundreds of examples from all across the country from which to make our comparison. Because it's the most commonly used method to demolish high-rise buildings. So this is what a high-rise looks like when it's being demolished with explosives. Controlled demolitions can be engineered in many different ways. Normally, the purpose of a controlled demolition is to remove the structure while avoiding damage to adjacent structures, and to do so very economically. So typically, a tall building like this is demolished by placing thousands of cutter charges throughout the columns and beams in the building, and then detonating them in a very precise order. Starting with the interior structure and progressing outward, and starting synchronistically timed floor by floor. Destroying the interior columns allows the weight of the building to pull the exterior inward, avoiding damage to adjacent structures. And destroying the building from the ground up allows the weight to be harnessed to do much of the destruction. So the result is an implosion, producing a vertical, symmetrical, free fall speed or acceleration of collapse into a consolidated rubble pile that's broken up and ready for shipment. Now this is a feat that only a handful of companies in the United States can accomplish. So let's keep these features in mind as well as we talk about these three main destroying forces, if you will. So what do we have? We have typical controlled demolition, starting with a sudden onset of destruction at the base, a straight down symmetrical collapse into its own footprint. Demolition waves remove column support. That's how it happens. We have a free fall speed of, a free fall acceleration gets faster and faster through the path of what was the greatest resistance, the thousands of tons of steel designed to resist that. So it has to be removed. So we have the total dismemberment of the steel structure, so it's broken up and ready for shipment and loading. Minimal damage to adjacent structures, ideally. Sounds and flashes of explosions are associated with controlled demolitions. Enormous clouds of pulverized concrete and pyroclastic-like cauliflower-like forms. Sometimes we have squibs or mistimed explosions that go off at the wrong time. And chemical evidence of cutter charges. So if you have any one of these, you have direct evidence of explosive destruction. Interestingly enough, fire can't accomplish any one of these, let alone all 10. So, if we have all 10, certainly we know we have a controlled demolition. This is how we approach the scientific method in applying what we've inherited in our Western civilization, which allows us to winnow error from truth. We do background research after forming a hypothesis. And so that's what we're doing here today, a little bit more of background research than we ever saw in any of the reports given to us by NIST, the National Institute of Standards and Technology, FEMA, or the 9/11 Commission report. Now, if we have governmental documentation, expert corroboration, they agree that's a controlled demolition, foreknowledge, because we know in advance, right? These things are planned and set up. And then we know darn well we have proof beyond a reasonable doubt of controlled demolition. So this is pretty straightforward. Let's compare now those features of a classic controlled demolition to Building 7. Now, how many of us have no idea what I'm talking about when I say Building 7? A lot. Let's get a count. Go really high. This is important. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 27. So 27. No, on 7. I didn't know anything about it before 3 years ago when I first found out about this, listening to the radio. All of a sudden, Building 7. Look at this building. Why didn't we know anything about it? It's a 47-story skyscraper, easily the highest building in 33 of our states. It was only dwarfed next to what was at one time the tallest buildings in the world, Twin Towers. So it was a football field away from the two Twin Towers. It was not hit by an airplane at all. And it collapsed at about 5:20 the afternoon of 9/11. So here's the building in its full glory, and let's see what happens. The North Tower goes down, and there's some beams that hit it, and they start some small fires, as you'll see in a moment. But let's compare the features of controlled demolition, if they exist, at Building 7 to the typical features. Starting with, is there an onset of destruction at the base of this sudden onset at the base of the structure? Let's listen to Daryl, a medical student, interviewed that evening on 9/11.
Because it was on fire, the bottom floors of the building were on fire, and we heard this sound that sounded like a clap of thunder. Turned around, we were shocked to see that the building was, it looked like there was a shock wave ripping through the building, and the windows all bumping out, and it was horrifying. And then, about a second later, the bottom floor caves out, and the building followed after that, and we saw the building crash down all the way to the ground. We were in shock, and then the worst part.
Sudden sound of a clap of thunder, shockwave ripping through the building, windows busting out, and then the building coming down. Look at the order of these statements and activities. It becomes really, really important. Do we have a straight down symmetrical collapse into its own footprint? Let's listen to Dan Rather narrate this, our first look at Building 7.
What you're seeing are eye shots. Now, here we're going to show you a videotape of the collapse itself. Now we go to videotape the collapse of this building. It's amazing. Amazing, incredible picture work. For the third time today, it's reminiscent of those pictures we've all seen too much on television before when a building was deliberately destroyed by world-class dynamite to knock it down.